two images was the same as the model. So the model is extracting features that go in the same direction as your intuition. So I'm going to go a bit more in depth with results of Mali. So again, this is the map of Mali as published in the report. So when they made the food security assessment, they collected the data, created the report, and that's the map of the results. So they are here is a bit more granular than in Tanzania. They're at admin 2. So meaning that the survey design makes the data representative at admin 2 or district level. So you're only able to show maps at district level. Here the indicator is again proportion of poor and borderline food consumption. So different colors. You can see here more red. The Sahel region is doing a bit. The food security situation is a bit worse in the Sahel region than in the south. But again, if you want to know here if there is some pockets of food insecurity, you don't know. So we go to the clusters. So the clusters is the data that's behind this map. It's where the enumerators went, and we aggregate the data at cluster. So we compute the food security indicators. We average them for the 10 people that have been interviewed in each cluster, and we have a score for these 10 people. So if I plot this score for 10 people, you have a lot of points here, you have some red in some location, but sometimes the red are very close to the green, so you can see that if you average here, I don't know what's going to be the resulting color, because the red and green together.
So which percentage is poor and which is on the borderline?
So here it's the color is the poor and borderline, yeah. So if you see dark red, it means that there is probably more than 80% of households on an average of 10 people that have poor and borderline food consumption. So again, we extract the features in this location. So for hospitals, we get the location of hospitals from OpenStreetMap. We compute the distance to hospitals. Night lights, we get them from the NASA satellites. And we put that into a model of the other features that I showed before, and that's the final map we get. Prediction map, here at, I think, 10 kilometer resolution, yeah. And here we can show, again, the proportion of poor and borderline at a much higher resolution. So this is a model, meaning that you have some prediction errors. It's not as good quality as the aggregated map at admin 1 level or admin 2 level, but gives a good idea of what's happening. And in particular in areas that have a lot of mix of red and green, you can see more where the pockets of reds are and where the pockets of green are. So you don't have any color in some location, in the north in particular, because we only make predictions. When I say prediction, it's spatial predictions. There is no time component here. So it's estimating the food security situation in a place where there was no survey, where no survey was conducted. So we don't want to make these predictions in areas where no one is living or very few people are living. So we filter the results, or we filter them before actually, to only make predictions in places where you have at least, I think, 100 people living or something. Otherwise, we would end up by making food security prediction in the middle of the desert or in the middle of the water, in the middle of a lake, and then can be counterintuitive for the model. Like the model can behave strangely and make strange prediction, and also for the user of these maps. Like no one is living, you don't want to send people because you think the situation is doing bad. So these maps, these final results maps, country office usually don't like them so much because it's a raster. So raster to discuss with partners, it's not very easy. Like if you want to allocate resources on a raster, it's pixels. People prefer shape files. So we re-aggregate this raster to an administrative level. So that's what we've done in Mali. We've done it at admin 3. So admin 2 is the original map of the report, remember? And admin 3 is the prediction map we can make from these models. So it's just an aggregation of this, and we put it back to admin 3. We don't just average the value in an administrative area. We do weighted average, and we weight by the population. And the population, we get it from WordPop. I don't know if you're familiar with WordPop. It's a group, it's an academic group that make these maps at 100 meter by 100 meter of population estimates. And so again, they also use a model. So it's a lot of uncertainty in each model, and then when you combine them together, you can have strange results. But that's the best, to my knowledge, that's the best global population figures we can get at high resolution to create this kind of maps. So this is the map of poor and borderline food consumption.
Sorry, and what was the resolution of your pixel? The world map
Here's
is 100 meters, and what was the resolution of it?
the final 10 kilometer, I think. So we sum WordPop by 10 kilometer before doing the raster calculation. So we have tried in a food security assessment, typically like a CFSVA, you have tens of indicators. You have everything from poverty to food security and different dimensions of food security. So we've tried a bit with everything. Here's some results. And how do we evaluate the results? We look at the R squared of a final regression model. So the R squared is how well the model compares to the mean. So if you make an average prediction in an area, like if you predict the average of a location, you get the R squared of 0. And everything that's above 0 is doing better than average. But you can still see that for some indicators it works better than for others. So for asset score, 70% is considered as very good. And for other things, 46%, the one I was showing. So the quality of the prediction we make with these models vary a lot. It varies on the context. Like in one country, if we do it in one country, if we do it in another country, we will not get the same quality of prediction. But it also varies within a country by indicator you're trying to map. And if I look at them, my impression is that it works much better with structural indicators that qualify the situation of the household, but the long-term situation. So things like asset score that doesn't change every week or every month, and things that have more temporal component, that are more seasonal, more food security type of indicators, it works worse. And it's not coping strategies. I don't have it here, but it works badly with coping strategies because the predictions are made from things we can extract from satellite images, and there are a lot of things we cannot extract. We can try to get the sense of agricultural production with NDVI, try to get sense of assets from what we see from very high resolution images, but we have tried in places where conflict is the main driver of food security, and we don't have any features for conflicts here, so the results are much worse. Mali is a nice example. Senegal, we've had very good results, but sometimes we get worse results. So it's a work in progress. We try to add more features that encompass better the diversity of drivers, but we will not get everything for sure. Laure before presented some work with urban assessment. So we also been in touch with this working group in VAM and trying to make this kind of maps in urban settings. In Mali, again, if you zoom in Bamako, we're able to make the same kind of maps, but change the resolution and put it at 1 kilometer. And that's more useful for someone that for urban planning, or also urban food security assessments in general, to try to downscale an urban assessment or downscale a CFSVA in an urban area. I hope no one is from Bamako here, because otherwise I don't know if this makes sense. Like, we always have to discuss with country offices and people that know the situation if results make sense. And sometimes they make a lot of sense, and sometimes you have strange things happening. The model is not perfect. If there is a prediction done in an area and the schools have not been mapped, the hospitals have not been mapped, there is no night lights in this area, the satellite images have a lot of clouds and we cannot see well, but the prediction is going to be bad. But we try to have very diverse features that are globally available everywhere, so that we don't make so strange predictions.
Do you have any measurement of how weird or less weird is each result?
So we compare with the ground truth in places that surveys have been conducted, and we can see sometimes it's very red in our prediction, and it's very, or sometimes the opposite. It's very green in our prediction and very red in the survey. And you know, when you look at the cluster level, a lot of things can happen. And to conclude this project, I want to say that yeah.
How you come up with this threshold?
So this is a completely arbitrary threshold. This is just me playing with QGIS to have a nice map. So nothing official here.
And where are the in between numbers? 47.8, then 50.5. Where comes the in between?
So this is the FCS here. This is food consumption score, I think, or no, maybe it's 403. So in between,
there was a not continuous.
Yeah, it's there is an interpolation happening in the software, I think. To if you have FCS that's in between, it's going to make an interpolation of the colors to make a color that's in between.
Wait, the one with the percentage or in average?
4003, I think it's. I have to check. Not is it the 74 or 74?
Just the minimum and maximum value divided by 10, right?
No, if it's proportion in poor and borderline, it would be directly the percentage of poor and borderline. So if I have to check, but if it's a percentage, it would be the percentage 72% of people in this pixel have poor and borderline food consumption. But here I think it's the FCS score for 503. So it's the FCS score of a specific pixel. So it's not continuous, but it should be continuous, meaning that you have some values in between, and they are going to have a green. And you know, it's in QGIS, you make some interpolation between the colors for continuous scales. You can put depending on we can look at the result if you want.
The FCS stands for food consumption score.
Food consumption score, yes.
So if we under the guidelines of WAM guidelines that indicated if FCS is less than 50%, that means that is acceptable. And if it's greater than 65 and less than 75, then it's marginal and other is poor. Greater than 75 is poor.
if the FCS is under 24, it's
It's a band
considered as
guideline.
poor. Between 24 and 48, it's considered borderline.
Yeah.
And above 48, it's considered acceptable. So here in Bamako, everybody is acceptable, more or less. And with this prediction map.
No, it's not an average value. It's the information is the percentage of people, of household who has in poor and borderline.
Okay,
It's not
so
easy.
yeah, so we talk about two different things. From the FCS,
Yeah.
you create a proportion of poor and borderline, and from the proportion of poor and borderline,
Yeah.
you can do the carry classification and have the food insecure population. So that's, we have tried to run the models directly on the carry classifications, but the results are not as good as if you run them on share of food expenditures, for example. So you can you can try with everything, this kind of model. But the more, as I said, the more poverty-related or long-term household status, the better you will get in the results. So yeah, to conclude, the model is as good as the survey data that you put in. For example, here, so these are these are survey locations as we got them from the GPS of the tablets. So this is a very zoomed area. You see buildings here, and you see thousands of survey locations around these buildings. So, in your opinion, what happened here? Why do you have so many surveys around this building? It's a market? Okay, but this is a household survey, so you're not supposed to go in the market, you're supposed to go in every distribution site. So it could be a distribution site if you're doing some kind of M&E survey, you want to interview beneficiaries, go into the distribution site, but this is from Mali. So this is in Bamako, in Mali. When I zoom in Bamako here, and I zoom, I arrive to this location and I have thousands of households that have been interviewed in the same place.
Wow.
So it's
It's your office.
why is it my office?
No, I mean not your
The
office, but
DFP.
the office of that person, and he messed up his coordinates and attached them at the moment he was in the office instead of.
Okay, so
Connecting
yeah,
them.
that's more or less what happened. Remember here, so there is no clusters in the north of Mali. So at the beginning I thought it's because this area is very insecure, so we don't want to risk. It's desert. Yeah, it's true. So two things. It's desert, so no one is living, so you don't want you don't sample people in desert. You only sample in inhabited places, but still you have some cities. You have Kidal. You have a few cities. So the rules of sampling should make you select at least a few clusters in these places if you want to make a survey that is representative at admin 1. So yeah, the second thing I thought is it's because it's too insecure, so you don't want to send surveyors. They might have troubles with the armed groups that are in the deserts and stuff. But the true thing is that they sent some enumerators there, but they didn't send them with tablets, because the tablets get stolen often if they go there. So they send them with pen and papers to do pen and paper survey, old style pen and paper. And before analyzing the data, they have asked people to put back the paper surveys into the tablets. And that's probably the location of the house of the guy that has been paid to put the pen and papers in the tablets. And the tablet was each time extracting the GPS location, not at the exact same place, because GPS has some precision, 10, 20 meters precision, so you get some noise in that. But And this is an example just to show you that survey data is the key component here. The rest is automatically extracted from globally, you know, the NDVI, we get it everywhere. We don't get cloud because we take care of data. So we get the same NDVI value a bit everywhere, but with the same method. Whereas survey data, there's so many ways it can be strange that the model can behave strangely with this training data. So that's, for me, that's the main limitation of this approach. Is we're trying to make something that is very automatic. The end goal is to have a web tool that's, if you collect survey in your country, you don't have to send this survey to HQ, wait for 3 months and get the final map. We want a tool where you upload your survey data, you do 2 clicks, you wait a couple of minutes, and you can download the output prediction maps, and then you can play with it, and you get some scores on how good is it compared to other countries and stuff. But at the moment, the main blocker of doing this app is each time we try with new survey data, we find new problems in the survey data, the indicator is not the same as it was before, so we cannot treat it the same, the GPS are on and off in some location. So that's a limit, but I think things are getting better, and when people are aware of this kind of initiative, they also pay more attention in collecting GPS locations correctly. Because before, no one was using the GPS correctly.